now I would like to call the Mr. Shiraz, Dr. Pramod, our head of development, Dr. Salman. That UAE will replay the next 5 years in quantum technology and photonics.
Thank you very much, Lena, for your question. And I think you have asked about the roadmap of QRDC for the next 5 years. So I would like to explain you or link it with the International Year of Quantum. We asked that why the International Year of Quantum has been celebrated, and the answer was to mark the 100 years of the quantum technology since it was laid. But what is the message from this quantum year 2025? Like, I know that there were several items which have been highlighted. One is to create the awareness about quantum technology. Number 2 point in this year of quantum was about the collaboration, international collaboration, right, that has to be done between, among the countries about the quantum technology. And the third main point was about bridging the gap between the global south and the global north about the quantum technology. Like, as we all know that at this point, everything lies at the global north. The technology is confined to that region, and like the global south is still deprived of the technology, and the things are still under development. So at QuantLase, the vision that we have at QuantLase, it is inherited from our group's leadership. And as you are all aware that we are privileged to have to be the part of the group which belongs to the ruling family. So before the visions are laid or they are put into the writing, we already adopt them. Like, if you know, the Abu Dhabi Vision 2030 was laid in the year 2006 and 2007. But even before that, we started working on robotics as part of Royal Group that started in 2004. And similarly, the UAE Vision 2031 was launched in 2022. And QuantLase started even before that. Right? We started working on the quantum technology. So yes, I remember that we were at a group discussion and we have been asked that why UAE needs to develop this. When West is developing this already, why do we need to do this? And my answer to them was, okay, we understand that it's being developed at the global north, but why we should be left behind? Why we should not do that, right? And the question is, are we capable of delivering this? Are we capable of replacing the global technology giants? Maybe not, or maybe yes, right? But the first question is, are we capable of doing that? Okay, we are leaving the commercial and the business aside, that whether it makes sense to develop it here in the UAE and to market it, the UAE, market it out of the UAE to the whole world. The first question is, are we capable of doing this? Do we have the capacity? Why we should not develop our capacity? The vision is first to acquire the knowledge. If you have to develop something, you have to first acquire the knowledge. So yes, that's the vision that we are learning. We are doing research and development on the technologies which are already like as a buzz or as the hot technologies in the world. So QuantLase QRDC is also inheriting the similar vision that we should learn, we should work on the cutting edge technology, and why we should not be doing that. Maybe in next 5 years' time, if not in next 5 years' time, in the next 10 years' time, we might be developing the products which are in the lab now. And we are glad that with the PIPU, the Photonic Processing Unit that has been recently developed by the team, we should definitely commercialize it and we might project this as something which might replace the GPUs in the future. So yes, the vision is acquire the knowledge, get ourselves armed with the things, and then look into the commercialization of the product and making it a successful business case. I think I explained what you were expecting.
I got one more question, and this is both for Mr. Shiraz and Dr. Pramod. So as and you mentioned the role of QRDC, and throughout the year 2025, I think we achieved quite significant milestones in terms of the chip and the people, which we're really proud of. So what is your opinion, like what does QRDC right now need in terms of whether it's infrastructure or researchers or scientists or equipment that can actually place QRDC at the global landscape?
Yeah, again, I'll go back to the International Quantum Year and what have they explained as the essence or the message of the International Quantum Year is to build the ecosystem and the collaboration among countries. So yes, we have already taken that step, and we have developed. What we have noticed that the ecosystem is not present in the UAE. To bridge the gap between the global south and the global north, what we have to do is to develop the ecosystem. The ecosystem is there in the west, but it's not there. What does that mean about we are missing the ecosystem is, I mean, if you want to develop or if you want to convert your lab projects into a product, you obviously you are looking towards the PIC, photonic integrated chips. You have to have the design software, you have to have the testing labs. So QRDC has already taken this step, and we have established in this year some collaboration with different entities, and we are trying to bring that ecosystem in the UAE. And I believe that if we have the ecosystem available here, we should be on the track, and we should be developing our own products, and we should be marketing very soon.
As Mr. Siraz actually explained about this, because if you think about to deploy your system or your product from laboratory level to public domain, so you need to create your ecosystem. So without ecosystem, you cannot do these things. You cannot transfer your technology from lab to public domain. And there is a gap between these things. You cannot directly transfer your product from lab to public domain. You need to look for something which is the PIC, Photonic Integration Circuit. So PIC is the launch pad actually to deploy your technology from lab to public domain. So it's not easy to think, okay, create a photonic integration infrastructure, but you need to create your designing setup, designing infrastructure, testing infrastructure, fabrication, packaging. So all these things, it's not easy to develop all these things at the same time. So in this regard, we have established our strategic partnership with some European foundries, and we already work on it, and you can see the results, or you can see the real product in front of you. So yes, Mr. Siraj was right, and we need to create the ecosystem and of course, not only the ecosystem. If you look at very carefully, because in Middle East, it's very hard to find quantum scientists, really a hardcore quantum science. So we need to educate the people in quantum technology. So once graduated people, post-graduate people, PhDs, they are coming all together and make a bridge between industry and university. Because university is different environment, industry is different environment. So we need to make a bridge between these two. So that is why students from university institute actually come over here, take a hands-on research experience, and then implement over there. And of course, industry person should go over there to understand the science behind the technology. So we need to create a bridge between university and institute. So this is the things. And another thing is that because everything comes from the market demand. So you need to look for what are the used case to design your technology. So these used case actually comes from the market. So again, the investment come into picture. So investor always think about the market demand, and then he is ready to invest. So it's a investor perception to invest money on a particular technology. It's not like that some technology is very much fascinating, so investor will invest money. No, whatever he make a perception about market demand, and then he's ready to invest on it. So market demand come into picture, and where does the market demand come into picture? It's a normal people. So you need to educate normal people, then they understand what kind of technology is this particular quantum. Because if you go to the village or outskirts from those metro cities, people don't know what is quantum. So you need to educate the normal people to introduce quantum and give this information to at grassroots level. Then they start giving the demand, and then market this demand actually will come into the market, and then investment and everything. So of course this whole things actually combinedly the part of ecosystem. So we need to create an ecosystem to transfer your technology from idea to product level and to the public domain.
So my next question is, both Mr. Shaz and Dr. Pramod mentioned EPIC as the bridge and what is needed for QuantLase to basically transfer what we have, the different projects we have to products. So our head of product development, I would like to give this question to you. So which one of these products that we have in QuantLase that you see is the closest to actually in a product form that commercialize it within a year or 2 years?
Thank you very much, Hasina. Yeah, I appreciate the question. And as Dr. Pramod said, PIC chip technology, it's not just a technology, but it's treated as a vehicle for launching products. The broad comment about the ecosystem that Mr. Shiraz and Dr. Pramod made, yes, that explains very much why we need to study from top to down in terms of the technology, market demands, investors' perception, and ultimately connect a bit to what normal people think about the technology use case. When you connect all these dots, obviously chip technology is a very ideal platform for productization. Now, if I connect this dot to the question that you asked, yes, over here, I'm very proud to lead this work because our flagship project, Photonic Intelligence Processing Unit, it is actually the main project driving the chip work as well. What we've achieved so far in the past 6 or 7 months, and the result of that is the chips that I'm holding right now. So this is the photonic matrix multiplication, which is ultimately what we are doing with the photonic processing. In terms of the product, so I'd answer your question in 2 dimensions. One is what's the potential for productization? Yes, I think this creates a very synergistic combination of combining the photonic intelligence idea, obviously what design we've got here. I've only converted Dr. Pramod's vision into chip-scale components. So this is a very strong and a very powerful combination when you try to implement the photonic intelligence work on a chip scale. So that's the first dimension. The second dimension is, yes, it's got a very strong potential for market and productization within the next year. If we look at that, in terms of the progress that we've already made, we've already implemented and designed a matrix multiplication engine on silicon photonics chip. In terms of what we see progress in terms of the next year, the first milestone that we are hitting for sure, which is what Dr. Pramod mentioned, it's a strategic partnership with a leading design company, we will get the design ownership of matrix multiplication, which means that technically, within the next year, if we've got clients who want to manufacture silicon photonics or basically any matrix multiplication design, we can sell. We can sell this as a design IP product. And this in itself is a very big win, because this means that you can ultimately position this as your product. And this is very different. We are not exporting anything, we are developing our own product. So that's the first milestone. Second milestone, which we definitely see achieving within the next year, is we will have a functional module for matrix multiplication. So what's the difference between a module and a chip? We've got the main engine of matrix multiplication, but within the next few months, we will have a big module, a box, where this chip would eventually be fitted. And that module would basically be a miniaturized version of what we've got in that lab, the PIPU infrastructure. Obviously, in a basic demonstration, it won't be in terms of specs, in terms of performance metrics. It would be different because it's different platforms. So, to summarize, yes, there is a very strong potential for productization because this is in fact not productization. And in terms of the milestones, yes, within the next few months, we are en route to hit tangible, in fact, milestones. Some of that we've already released the milestone. We've already seen the progress. And what we are on now is a path to, is actually a pipeline of deliverables. It's not just one deliverable. We started with design, we've got the chip, we will have the module, we've got the intellectual property ownership. This is a big deal. And I'm very proud to say that obviously with the support of executive management of the QRDC, we have delivered what no other group in the Middle East has delivered so far. Very confident about this.
So, in terms of, I think Mr. Shiraz asked in the previous panel about the QRG. QRG is one of the main units in QuantLase after DPI. So, what is your perspective on transforming this from a landmark to a chip? What is the challenges that you see as the principles of this process? If you can explain this briefly.
Thank you, Ms. Lina. And my name is Dr. Azam Ali Khan, and it's my pleasure to visit here and to be part of this research and development. My project is focused on quantum random number generation with the help of chaotic lasers. So at the core, this technology produces a high quality, unpredictable true random number at very high speed, and which is very useful in encryption, cybersecurity, digital data protection, and quantum secure communication, and complex machines. At the core, what we are doing, we are using semiconductor laser, which naturally have some tiny quantum fluctuation. We drive the semiconductor laser to a chaotic medium where this quantum fluctuation amplified, and the whole system becomes a powerful source of the entropy. And by combining this quantum noise and very fast chaotic dynamics, we are able to produce a very highly random and predictable random number at very high speed. And you see, now every world is shifting towards the AI-based systems and autonomous networks and fintech expansion. So the security of the data infrastructure is the priority of the nations. And with the help of the plurality technology, we are building the foundation technology which ensures UAE's digital infrastructure to remain secure and resilient and global competitiveness. And as far as the development key achievement regarding this project, so we are proudly say as Dr. Mr. Shiraz sir, Pramod sir tell about the developing the ecosystem. So we basically design and develop all the systems, which is pushing the homegrown innovations, and this will this will open the path for scientific publications, patent, and eventually lead to the local manufacturing and business opportunities. So we have already developed the system, and our system is meet the standard and industry standards, and people now we are in a position we can supply this and the numbers through the internet and through the cloud, and from the paper request model or the license model.
The next question is about the chip.
I just wanted to add this thing. QRNG is very interesting phenomena. So, we are living in an information age, and we are dealing data every day. A huge data is transferring one place to another place. So, what exactly you want in real life? You want your safety, security, and the speed. So you need to maintain two things in real life. If you really make an integrate your QRNG system with the available infrastructure, so you need to maintain these two things: speed and security. So the problem is that the moment you talk about the QRNG, so it's a quantum random number generator. But you know what happens when you integrate this system with the digital electronics, so you lose the quantumness, because everything is being detected by your electronics. So finally you are converting your optical information into electrical information, so you are losing the quantumness. The problem is that for transfer this technology of chip scale is that without detection, how to maintain the quantumness. So I mean, if you look into matter very carefully, what exactly you are doing in real life. You are living in classical world, which is based on electronics, or digital world, but you are doing your experiment. You are extracting quantum information at that particular world. So these two worlds have different speed. So optical world is very fast and electronical world is very slow. So this is the main key challenge: how to establish a bridge between these two worlds, because you want to extract same information in quantum world and want to implement in classical world without detection. Once you detect your optical field, everything is washed out. So I know I've been encountered many companies and nowadays they are giving quantum random number on chip scale. How can it possible? How can you maintain quantumness on electronic chip? Because finally you are putting detector. You are using laser and some light manipulation and control in between, and then detector. So the problem is that because you don't have optical infrastructure to use as it is your QRNG, because you are working with electronics. So you need to convert your optical domain into electrical domain to make it integral part of available infrastructure. So this is the reason. This is the reason you cannot say it's really a quantum, because you lose the quantumness once you detect it. So in the previous discussion, I already discussed in this regard. We need to create an ecosystem. We need to create that infrastructure where you really use optical world to really maintain the quantumness. But of course, once you convert it into bits using detector, it's random. I'm not saying that it's not random, but you are losing the quantum flavor, because the security actually comes from the quantum nature, not the number. So, but on the other hand, you are maintaining the speed because you are using chaotic world. So chaotic is very fast, it's terahertz. So you are really working with the speed of available infrastructure, internet speed. So there are two things: randomness and speed. So suppose you maintain only the randomness, so any quantum base source, single photon generation, or spontaneous emission, all give you a quantum randomness. But the problem with that, the emission of photon with the the single quantum dot or single photon is very slow. The emission rate of these photon are kilohertz range. So you cannot compete with the internet speed with kilohertz range. But on the, so you are maintaining only the randomness part, but you are losing the speed part. So how to compensate these two things, speed and randomness? That is why we have chosen a desirable or beautiful platform of chaos. Chaos is, of course, chaos is not quantum. It's a classical phenomena because it depends on some mathematical rule. So it's not classical, it's a deterministic phenomena. It's not non-deterministic. So we have designed this experiment in such a way that you are not losing quantumness, but is still maintaining the speed. So this is particular regime in external cavity semiconductor laser, where you find a particular regime where you maintaining the quantumness but improving the speed. So that particular regime we find near about the threshold. Because near about threshold, you are playing with two worlds. One is quantum world, one is classic world. But you have no idea where the quantum world actually start vanishing and the classical world is going to appear. So this is the coexisting world near about threshold of any laser system. So if you are smart enough, you design the setup in such a way that you maintain the quantum phenomena and amplify this quantum seed in the presence of classical light and reach at a detectable level. You detect that quantum seed with amplified form and then convert it into digit. Then you can say that it's really a quantum. But originally, quantum emission is not really compatible with your current internet speed. So we need to think about in this regard. And for your second question, what are the difficulties of transferring this QRNG on chip scale? Because silicon-based chip is not actually capable to get lays. So you have to separately use the laser system, and of course you can fabricate some optical part on the chip scale, and also detector you need to detach from. So you cannot put all the optical component to make it functional things on chip scale is not possible on silicon chip. We need to think about them in terms of material context. So we need to look for this what is indium phosphide. So indium phosphide, if you use, you can fabricate all the optical component on a single wafer. So this is the solution, but it's difficulty. There are a lot of benefit and drawback for every technology. So if anyone want to discuss more about in this regard, so Dr. Salman is here to discuss in detail all these things, how to transfer this QRNG from lab to fab. But currently, we are in situation we can provide cloud-based entropy source for daily use or for real life application. If you want to create a keys for QKD system, or for if you want to create OTP for banking transaction, or some other some research project like a Monte Carlo simulation. If you want to run your Monte Carlo simulation based on really quantum random number based system, so we are really ready to give this entropy source for depending on the requirement.
So my final question, okay, and of course we have to bring the Photonic Intelligence Processing Unit. So when we started this, or Dr.Pramod, so when we started this at QRTC, the main function used to come under decision making, and it was mainly for the processing of financial.
Yes.
Now there's this question of can the people play a role actually in something as a tool or something in which it can work for the error correction in quantum.
Yes.
So I
Yes.
would like to.
Yes. It's very.
And so this
Yes.
is for Dr. Pramod.
Yes.
From Mr. Shiraz, I would like to see what potential that you see in terms of business for the people?
Thanks, Lena. It's really very interesting questions actually, because the PIPU, I gave this name, is Photonic Intelligence Processing Unit. This PIPU is not only developed for the inference or training for financial data, because I have a broad vision about this PPU, because I know many used case available in the market, particularly in the quantum technology. So do you think you really get a error-free quantum computing in your real life? Because the problem is not a technology, the problem is not a science. You cannot control quantum world outside from the quantum world, because this is very fundamental nature of quantum is the error. Quantum computing is based on probability. It's a probabilistic behavior. Any qubit is a probabilistic behavior of the things. So if you use qubit for making quantum computer, you can use it. It's not an issue. But the problem is that your answer would be in a probabilistic form. Your answer would not be in a deterministic form. You cannot have a definite answer. You always have the answer with error, because your quantum processing is error prone. So error is not coming because of your technological issue or because of scientific. No, it's not coming from your technology. Of course, you can minimize error by transferring your whole technology on chip scale. And other thing is that if you transfer your technology, like, because qubit could be possible on atomic based qubit, ionic based qubit, but if you design your qubit based on photon, so you, of course, you are getting rid of temperature fluctuation in your life, which is the fundamental source of error. So if you transfer your technology, instead of using atomic or superconducting based qubit, ionic based qubit on photonic based qubit, so you are actually minimizing the error, but still you cannot reach at the error free quantum, because the very fundamental nature of qubit is still there, which is probabilistic. So this is very interesting question. Not now, everybody is asking, can we really get a fault tolerant quantum computing in real life? Is this really a hype of deploying quantum technology, or what is the reality behind that? So as far as my understanding is concerned, there is no way to get rid of error-free outcome from the quantum computer, unless and until you need to rethink of quantum phenomena. Maybe we are on the wrong track. So we need to rethink about the quantum phenomena, and we need to rethink about how to store our information, how to process our information based on qubit system. So this is the thing. So many people ask me, so you are talking about only the problem. Do you have any solution? So PPU is the solution of getting error-free quantum computing without disturbing the quantum processor. Why? Because PPU is capable to detect any abnormal anomalies in your data. We are working on finance and all, so we are capable to detect anomalies. So our plans to integrate PPU as a error syndrome detector with the quantum processor. So because the problem with quantum processor is that if you detect, if you measure, if you see the quantum bit to check the error, the wave function collapsed. So it means you are adding more error of detecting the quantum bit. So there is no way to detect the error by measuring the quantum bit behavior. So I'm looking for, is there a photonic platform where we can actually probe the error syndrome without measuring. So PPU will give you this platform to detect the error and maintain the error, compromise the error without detection, because this device is based on interference. and interference pattern will give you the signature of the error correction. Because suppose you have 10 qubit, and for 10 qubit you have a particular interference pattern. If their one bit is getting disturbed, the pattern of interference pattern will get disturbed. So you easily recognize the error is coming. So this is the best way to make the integral part of quantum processor. So PPU will work as a error detector, will be an integral part of quantum computing. So if you add PPU as an integral part of quantum computing, then there is a possibility. I'm expecting this result, you will get error-free quantum computing.
Lina, you asked me about the potential of the photonic processing unit that has been developed at QRDC. So I'll not give you the potential about the PPU unit directly. I'll give you some background so that you can understand that what potential lies there in this development. If you remember, when the classical computer, we started working with the classical computers, they started at some kilohertz speed. Then we came to like 25 megahertz computer, then to 100 megahertz, and now we have reached to gigahertz. The technology developed very fast. From megahertz, we reached to gigahertz very quickly, but we got stuck at some gigahertz. And then after those gigahertz speed, we are unable to go beyond, right? I mean, do you know why are we stuck at that 4 or 4.5 gigahertz with the classical computers? Why we cannot go beyond that? That is because, I think most of you know that because of the material limitation, that the switching of the transistor, it is beyond the switching limit of the transistors, right? You cannot differentiate if it's a 0 or if it's a 1, if the transistor is on or if it is off at that gigahertz speed. So what is the solution? The PPU is working at the light speed, right? If this PPU, and if we, like as you mentioned that we have started working with the financial data, if we can if we can expand the scope of the PPU and we can get into computing, then something working at the light speed is an answer to that limitation that you have reached with the classical computing. So I think with this background, you can explain what potential lies with that.
Thank you so much for the discussion. I'm just thinking if any of the panelists would like to give a final remark on this statement.
Thank you very much. Based on my time here, the experience here of working on the projects which are really cutting edge, I'd like to make one remark which touches on the point of QRNG, for example. In addition to the matrix multiplication chip, right now, obviously, as I mentioned in the introduction, there are a few other projects where we've taken initial steps, but there are some confidentialities because of which we cannot reveal all the details. But I can tell you that we've taken some steps on a number of very interesting projects, including initial feasibility and supply chain mapping on the QRNG on-chip implementation. That's a very nice piece of work. And why I made this point is because QRDC is one of that, it is that platform. It's not just a lab. From what I've seen, it's not even just a research and development center, it's actually a strategic platform. What I mean by a strategic platform is from this platform, we've already started engaging the cutting edge of industry to implement our projects. And as one of the comments from our industry partners, when we were designing these chips, we got comments from them that this is something which they've never seen before. And it's like we are testing the extreme capabilities of our partners right now. The design of this was not so straightforward. Obviously, given the limitations on export controls, this is, by the way, another dimension which we are really proud that we touched for the very first time. We're the first group in the Middle East to have mapped the supply chain of EU in context of the trade restrictions and export controls. We've got these comments from a number. Currently, we are going through the testing and packaging. And it's not so straightforward to design a test framework for matrix multiplication because there are so many ways you can project this information. And given our unique positioning within the ecosystem here, we really take pride in being the first group to develop really cutting-edge technology. So in terms of a final remark from my side, I would say we should all be really proud of what we are doing here because I can tell you from my experience, and this comes from the feedback directly from the EU ecosystem and tech innovation companies, that what we are doing here is it's not a straightforward project, and it's like testing the extreme capabilities of our strategic partners, and this is one of the reasons that we've seen growing recognition of QRGC. We've seen Optica interview, Optica recognition. We've seen EPIC, we've seen strategic partnerships, MOU, and more to come in a very, very near future. So obviously, from my side, I can say definitely we're all really proud to be associated with QRGC because it's really, what we are doing right now is really the first one in a lot of things that we're touching right now, and I'm very proud to be associated with this platform. Thank you.
That's it.
So in the closing remarks, I would like to add that, as I mentioned in the vision of QRDC, that it's a twofold vision. First is to develop the capacity and the capability, and the second is about the commercialization and the business case. So for the capacity and capability development, you are the team. You are our arms and strength. So give us the capability and we will take it further and we will make it a business case for you. Thank you very much, all of you, for your time. Thank you.
Thank you. Thank you.